Assalamu alaikum dear students. We are discussing this exercise 9.3. Today we will discuss it again. And question number 14 of this exercise 9.3 is the sum of the first three terms of GP is 16 and the sum of the next three terms is 128. We have to find A first term or common ratio and S and sum of n terms. Now let A be the first term and R be the common ratio. Then first term is a, second term is a r, and third term is a r square, which implies that their sum is 16. Name it equation first. Again, third, fourth term, fifth term, and sixth term, their sum is 1 to 8, which implies that a r cube, which is fourth term, plus a r 4, which is fifth term, and a r 5, which is sixth term, their sum is 128. Now taking r cube, because r cube is minimum, taking r cube common, we get a plus ar square into r cube is 128. Now a plus ar square is 16. It is 16 into r cube is 128, which implies that r cube is, after simplifying it, 2 raised to power 3. Hence r equals to simply 2, because when powers are same, basis should be same. Now put r equals to 2 in equation first. When we put equation first, we get simply 7a equals to 16, which implies that a equals to 16 upon 7. We know that the sum of the n terms of GP, whose first term is a and common ratio is r, is Sn equals to a into 1 minus Rn upon 1 minus r, or Sn equals to a into Rn minus 1 upon r minus 1. So substituting these values, we simply get 16 upon 7 into 2 raised to power n minus 1 is the required sum of this n terms of the GP. Now the question number 17 is, if 4th, 10th and 16th terms of GP are x, y and z, prove that x, y, z are in GP or this sequence is geometric progression. Let ar square, ar cube, so on to be the given GP. This means that first term is a, common ratio is r. We know that nth term is a n equals to a r raised to power n minus 1, which implies that a4 is ar cube equals to x by given, which implies that x equals to ar cube. 10th term a10 is ar 9 is y, because 10th term is given to be y, which implies that ar 9 ar raised power 9 is y. Similarly, a16 is ar raised power 15, which is z, which implies that z equals to ar raised power 15. Now we will check whether this is GP x, y, z or in GP or not. This means that we have to find their ratio. Y by x is a into r raised power 9 upon a into r raised power 3, which is r 6. Similarly, z by y is a r 15 upon a r 9, which is again r 6. This means that ratio is same, hence x, y, z is the finite GP or in geometric progression. Find the sum of n terms of given sequence. Sequence is 8, 88, 888, so on. So this means that each term contains 1, that is first term has 1 8, second term 2 8s, third term 3 8, so on and so forth. Let Sn denote their sum. This means that Sn is 8 plus 88 plus 888 plus 4 times 8 up to n times. Taking 8 common, so we get 1, 8 into 1 plus 11 plus 111 plus 1111, so on up to n times. Now multiplying and dividing by 9, we get 8 by 9 into 9 plus 99 plus 999 plus 999, 4 times 9 up to so on. Now this 9 can be written as 10 minus 1, 99 can be written as 100 minus 1, 999 can be written as 1000 minus 1, so on and up to n times, which implies that 89 upon 8 by 9 into, now this 10, 100, 1000, so on and so forth up to n times, plus minus 1 minus 1 minus 1 minus 1 up to n times. Now this minus 1 minus 1 minus 1 up to n times means minus n. Here this clearly this sequence 10 10 100 and 1000 like this up to n times is GP, because ratio is 10. First term is 10, which implies that the sum of the n terms, because we have to sum it up to n times, which implies that Sn is a into or n minus 1 upon or minus 1, which is 10 upon 9 into 10 raised to power n minus 1. So 8 by 9 into 10 by 9 into 10 raised to power n minus 1 minus n is the required sum of the n terms of this GP. Now the question number 23 is, if the first and nth terms of GP are A and B, P is the product of n terms, we have to prove that P square is AB raised to power n. Let A or cube so on to A or n minus 1 be the given GP, which implies that A equals to first term is A, nth term A n is A or n minus 1 is B. Now P is the product which is sum of the product of first n terms, that is A plus A into A or square up to A or n minus 1. Here we have n is, so it is A raised to power n, and we have or square up to or n minus 1. When we multiply these orders, we simply get or raised to power 1 plus 2 plus so on to n minus 1. We know that sum of first n terms is n into n plus 1 by 2, which implies that the sum of the first n minus terms is n into n minus 1 upon 2. So squaring both sides, P square is A raised to power 2n into or raised to power n into n minus 1. Now this A raised to power 2n can be written as an into an, and this or raised to power n into n minus 1 can be written as or raised to power n minus 1 whole raised to power n. Now combining these two terms, an and or raised to power n minus 1 raised to power n, we simply get a or raised to power n minus 1 whole raised to power n, because by the indices laws, which implies that P square is A raised to power n. Now this A or n minus 1 is B, which implies that Bn, hence P square is A and Bn. Now the question number 29 is, if A equals to arithmetic mean and G equals to geometric mean between any two positive numbers, prove that the numbers are A plus minus root A minus G into A plus G. Let A and B be two positive numbers, then by definition A is arithmetic mean is A plus B upon 2. G is geometric mean, it is root AB, which implies that from this first A plus B equals to 2A or A equals to 2A minus B. Here G square is AB, which implies that G square is simply by putting A equals to 2A minus B, we get 2AB minus B square. Simplifying this, it is B square minus 2AB plus G square. Now here we have to find B, which implies that it is quadratic in B. Here A is 1, B is minus 2A, and C is G square. So in quadratic equation, AX square plus BX plus C, X is minus B plus minus root B square minus 4AC by 2A. Substituting these values, we get B equals to A plus minus root A square minus G square. But now A square minus G square is A minus G into A plus G, which implies that B equals to A plus minus root A minus G into A plus G. But A is equal to 2A minus B, which implies that 2A minus B minus A, because B is here A plus root A minus G into A plus G. Now this minus makes plus minus as plus minus. So we simply get A plus minus root A minus G into A plus G. Hence in both cases the two numbers are A plus G into A plus minus root A minus G into A plus G. Now the last question is, what will rupees 500 amounts to in the years in 10 years after its deposit in a bank which pays annual interest rate of 10% at the rate of 10% compounded annually. So here we have a person deposits rupees 500 amount in an account for 10 years, and this bank pays annual interest rate at the rate of 10%. We have to compute what will be the amount after 10 years. Amount deposited in the bank is rupees 500. We know that at the end of the first year, amount will be P into 1 plus R, where P is the principal amount and this initial amount which is 500. R is the rate. Here rate is 10%, which implies that R is simply into, when we convert this rate into fraction, it is 10 upon 100, which is 1 by 10. We know that compound interest is calculated by P into 1 plus R by N into NT, where T is the time. Here time is first year, that is 1 year. N is the number of times the interest is applied. Here this interest for 1 year is applied only one time, so N is here 1. So which implies that after simplifying this, at the end of first year, amount will be 500 into 1.1. Similarly, at the end of second year, this becomes the principal year, this principal amount, which implies that amount at the end of second year will be 500 into 1.1 into 1.1. Similarly, at the end of 10 years, amount will be 500 into 1.1 into 1.1 up to ten times, which is simply 500 into 1.1 raised power 10. So this is the required amount after 10 years. Here you can calculate it directly by putting t equals to 10 and n equals to 1, because for these 10 years we have to this interest is applied only one time, so here n is 1. So this is the required amount. So in this way we completed this geometric progression. Inshallah, in tomorrow's video lecture we will discuss this concept of series. So thank you.